Hello, my name is Edwin Munyao. I'm the product marketing manager by Infineon for PROFET Plus 2 or high switches in automotive. Today I'm joined by Andreas Mangler from Rutronik, the strategic partner by the company. So, Andreas, do you have any questions for us?
Yeah, I've seen the new package is quite small, and the smaller footprint, the smaller pin pitch means also a smaller power pad at the bottom of the device. So what does that mean for my thermal management on my PCB layout? So what is your recommendation regarding passive cooling?
This is a very good question. First of all, the first thing we targeted with the new technology was to address space saving. And we addressed this by miniaturization or shrinking the package from the previously DSO14 package, which was very big and body size 14 package, to a much smaller TSDSO14 package, which is the body size 8. These two are representative of body control module. Your question regarding how we address the thermal budget that you have in your application was answered in a few ways. The first thing we did, we reduced the current consumption of the device. So we've reduced it by roughly 50%. Secondly, we reduced the internal resistance of the devices. So each of the devices has slightly a lower RDS on as compared to the previously. And then also we increased the switching speed, which made sure that you could reduce your conductive losses. And this made sure that you could keep the same thermal budget as you had before.
Okay. Yeah. So the current sense accuracy, which is I think less than 5% for the new family, versus the old family, I think it was roughly 8% accuracy for the current sense.
Yes.
And as you know, the inrush currents are often really high. Yes. What does that mean for my application regarding these benefits?
Regarding current sense accuracy, or kills as some people refer to it, our target was to make sure it's as accurate as possible and reduce it to the lowest number. With the PROFET Plus family, we had an 8% rating, and which was benchmarking the market. With the PROFET Plus 2, we even go much lower to 5%. With the 5%, there are a few benefits that you can benefit from your application. The first and foremost, and the biggest benefit that you can get in your application, you can reduce the size of your wire harness. And reducing the size of wire harness definitely brings cost to you. And that's, bottom line, what we're all achieving or targeting for.
Okay. So with the two high side channels, and additional two low side channels, maybe with discrete power MOSFETs,
yes,
I can also easily build up a full bridge motor control system, for example. So what is the maximum PWM frequency in such an application, in such a full bridge configuration?
Firstly, yes, you can configure to a full bridge application with our PROFET Plus 2. What we have defined in our passive slew rate for the device is around 10 volts per microsecond. With 10 volts per microsecond passive slew rate, we can specify or we can recommend a PWM frequency of roughly 20K to 25 kilohertz in our application.
And do you have some recommendation regarding the definition of the dead time in order to reduce the conduction losses?
This is something we have done in this way. In order to reduce the conductive losses or the losses in the application, we define the dead time as roughly 2 times the T-off. Our current T-off is roughly 110 microseconds. So in order to recommend you, we'll say 220 microseconds is a recommended dead time for your application.
Okay, thanks a lot.
Thank you very much.